All right, so let's jump right in. Imagine you're pretty new to cybersecurity, and suddenly everyone's talking about a vulnerability in this core Windows component, and it's called the Common Log File System, or CLFS.
CLFS.
Yeah, CLFS.
Mm-hmm.
And you might not be super familiar with it,
Right.
but think of it this way. It's like a detailed record keeper for certain programs on your computer.
Exactly. It's kind of running in the background, but it's really important for making sure things are running smoothly.
Right.
And you can recover data if something goes wrong.
It's like a digital diary
Yeah.
that helps you retrace your steps if something crashes.
It's a good way to put it.
So we have this essential component, this CLFS,
Right.
and then we get this SSD advisory warning us about a vulnerability.
Right. Things are getting interesting.
Yeah. So today, we really want to get to the bottom of this.
Yeah.
What exactly is CLFS? What does this vulnerability do, and why should we in cybersecurity even care about this?
It's about connecting the dots, between the technical stuff and what it could mean for security.
Absolutely. So let's start by breaking down CLFS. We found some good info from Microsoft Learn that explains it.
Yeah.
And it says CLFS is this logging service that works for both user mode and kernel mode software.
Yeah. Think of it like a super organized record keeper and make sure programs can go back and see what they did.
Like breadcrumbs.
Exactly. And that's super important for recovering if there's a problem.
And hold on. It also lets multiple programs share one log.
Yeah. It's wild. It's like a shared diary where different programs can keep track of what they're doing and share information.
Wow. So that's pretty powerful to see how things are interacting.
To understand why it matters, think of it like a transaction log in a database. You know how every single change is logged to make sure the data's good? That's what CLFS is doing, but for how the whole system works.
Okay. So we've established that CLFS is important for keeping our data safe and sound. But now we have this SSD advisory saying there's a vulnerability. What's the deal with that?
So the advisory zooms in on a specific function in the CLFS driver. It's called CLF space file persisted. Right metadata block. It's a mouthful. But basically, it's the part that writes important info about the log itself.
So it's kind of like adding labels and timestamps to those diary entries we talked about earlier.
Yeah, exactly. And the problem is this function doesn't double-check the results of another function it uses called CLFS decode block.
Okay.
So an attacker could use this to mess with the data going into the log, corrupt it.
So corrupt data in a log file.
Mm-hmm.
How does that turn into a big security risk? I'm not quite getting that part.
The important thing to understand is this isn't just about the data being corrupted. It's about what an attacker can do with that corrupted data. We're talking about privilege escalation.
Meaning?
An attacker could use this vulnerability to take over your whole system.
Whoa. Okay, now you have my attention. So how does messing with a log file lead to something that drastic? What are we actually looking at here?
Let's look closer at what the advisory says. It says this vulnerability lets a local user get higher privileges. And this is specifically on Windows 11 versions 23H2. And like we said, the problem is that missing check on what the CLFS decode block function returns. This can make the data get messed up, and a smart attacker can use that to their advantage.
So this isn't just some theoretical risk. They've actually made it work on the latest Windows.
Yeah, that's the scary part. The advisory says they tried it on Windows 11 version 23H2 and it worked, even though the vendor is saying it's just a repeat of something they already fixed.
Wait, so they're saying it's fixed, but the advisory proves it's not?
Yeah, that's the issue, and it's a big one, because if they can use this, it could be bad news.
Okay, so let's talk about what could happen. What are we really looking at here?
If someone uses this, the consequences could be pretty serious.
Right.
Imagine data breaches where your private info gets stolen or the system becoming unstable so you could lose data, and the worst case scenario, they completely take over your system and can do whatever they want.
Oh, man. Data breaches, system instability, loss of control. That's not good at all.
Not good at all.
So how does someone actually do this? How do they go from messing with a log file to basically controlling the whole system?
So this is where it gets technical. They have to manipulate how the CLFS log is structured to make the system run their own bad code.
Okay, I'm ready to go deeper into the technical side of this. Walk me through how it works.
Let's get into the specifics of how an attacker actually does this. It's a multi-step process, but understanding it is key to seeing how serious this is.
All right, lead the way. I'm all ears.
Remember how we said CLFS is like a carefully kept diary?
Yeah.
Well, imagine someone sneaking in and messing with those diary entries.
Okay, so I'm picturing this attacker sneaking around in those log files. But how do they actually do it?
The SSD advisory gets a little technical here, but I'll try to make it simple. Basically, the attacker wants to exploit that missing check in the CLFS base file persisted write metadata block function and use that to change the structure of the log file. They want to put in some messed up data that'll make the system react in a certain way.
So it's not like they're just randomly messing things up.
Yeah.
There's a strategy here.
Exactly. They know what they're doing.
So what are they trying to do?
They want to change something called a CRC32 checksum.
A checksum.
Yeah. Think of it like a fingerprint for each piece of data in the log file.
Okay.
And they can carefully change this checksum by messing with the data to a specific value. 0 FFFFFFFFFFS.
Okay, so they're targeting this checksum. Why is that specific value so important?
Because when that CLFS decode block function sees that checksum, it knows something's wrong.
Right.
It knows the data's corrupted. But here's the thing. Instead of trying to fix it, it just leaves the bad data there.
Wait a minute. It knows there's a problem, but it doesn't do anything about it.
Yep.
That doesn't sound very safe.
You got it. That's the whole problem.
Okay.
Now, the attacker has messed up data in the log file, and the system's just ignoring it.
So they basically planted a time bomb, and the system doesn't even know.
Now, for the really tricky part. Remember those diary entries? Well, they want to mess with how those entries are organized in the log file.
Okay. So it's not just the data they're corrupting. They're messing with the whole structure of the log file.
Right.
How do they even do that?
Think of it like this. The log file is organized in sections like chapters in a book.
Yeah.
And these sections have important info about the data. The attacker wants to force two of these sections to overlap.
To overlap, what do you mean?
So there's the container structure and the client structure.
Okay.
They want to make those overlap. Imagine you have two sheets of paper, and you lay one on top of the other. Some of the stuff on each sheet is going to be in the same place. That's what the attacker's doing in the log file.
I see.
By corrupting the data just right, they make these two important parts overlap.
So they're basically setting things up so they can get even deeper.
Exactly.
Yeah.
That overlap is important for what they do next. Taking control of the CLFS container object.
The CLFS container object.
Okay.
Another one of those technical terms.
Yeah. Basically, the CLFS container object is like the boss of everything in CLFS.
Okay.
It controls access to the log files, how data is stored, and makes sure everything runs smoothly. By messing with the log and forcing those sections to overlap, the attacker can kind of hijack this object.
So we've messed up the data, messed with how the log file is organized, and now they're in control of this important object. It doesn't sound good.
It's not good at all, because now they can use this object to make the system run their own bad code.
Okay, that's where things get really dangerous. So how does controlling this object lead to them having control over the whole system? What's the last step? So we've seen how an attacker can exploit this CLFS vulnerability.
Right. Yeah.
They corrupt the data, they mess with the log structure, and then they hijack that CLFS container object. They're right on the edge of taking over the system.
All right.
But how do they actually get in and get those elevated privileges? What's the final piece of this whole attack?
So this is where a key security feature comes in, or actually the lack of it. Windows doesn't have something called SMA Supervisor Mode Access Prevention.
Okay, SMP. And what would that do in simple terms?
The SMAP would stop regular programs from messing with the kernel's memory. Think of it like a security guard who checks everyone's ID at the door to make sure no one sneaks into the VIP area.
Gotcha.
Without SMAP, it's way easier for an attacker to get into places they shouldn't.
So the attacker can exploit this missing security feature.
Exactly. And remember how they took control of the CLFS container object? Well, now they can use that to create a fake copy of this object in regular memory. It's like a fake ID.
A fake ID that lets them into the VIP area.
Exactly. They trick the system into using this fake ID instead of the real one, and that gives them access to important parts of the memory that they shouldn't be able to touch.
That's pretty sneaky and dangerous. So what can they do once they have this access?
Now they have a lot of power. They can change pointers, which are like directions that tell the system where to find specific data. By changing these pointers, they can make the system run their malicious code.
So they're taking control of the system's navigation and forcing it to go where they want.
That's a good way to think about it. Wow. And the advisory actually explains how an attacker can do this to get past security checks and eventually write directly to the kernel memory.
And writing to the kernel memory is like...
It's like having the master key to the whole operating system.
Oh.
They can change settings, install malware, turn off security, you name it. It's game over for the system's security.
We went from what seems like a harmless log file to total system takeover. It's scary how connected everything is in cybersecurity.
It shows you how important it is to understand even what seem like small vulnerabilities and how they can be used. The SSD advisory makes it clear that this one is serious, even though the vendor is saying it's already been fixed.
Right. The advisory shows that it can be exploited even on the latest versions of Windows 11. So where do we go from here? What can we do to protect ourselves?
First, don't freak out.
Okay.
We know what the threat is now, and that's a good thing.
Right.
Second, don't just believe what the vendor's saying.
Okay.
Double-check everything. Look at their patch notes, see if they really fixed the problem, and test it out yourself in a safe environment.
So ethical hacking and penetration testing are important here.
Definitely. We need to see if their patch actually works. But even if it does, it's important to do more to protect yourself. Think layers of defense.
Like what kinds of things?
Start with the basics. Limit what regular users can do. The less access they have, the harder it is for an attacker to exploit this vulnerability. Have good logging and monitoring to catch anything suspicious, and stay informed. Keep up with security advisories and patches.
So be proactive and don't assume everything's perfectly secure.
Exactly. Cybersecurity is all about learning, adapting, and staying ahead of the bad guys.
Well said. I think we've covered a lot today. Any final thoughts for our listeners?
I think the biggest takeaway is don't underestimate any vulnerability. Even something that seems small, like a problem in a logging system, can have huge consequences. Stay informed, stay vigilant, and never stop learning.
Great advice. A big thanks to you for explaining all of this. It was really helpful. And to our listeners, thanks for joining us on this deep dive into the world of cybersecurity. Until next time, stay safe out there.